Welcome back to the Introduction to Animation Nodes tutorial series. If you came here directly, you might want to start at the beginning. All the info and links are in the video description below. In this video, we will learn about the input and output concept found many times in animation nodes. We will start by simply trying to animate this cube. So, first we need to access the cube. We go to Object and take the Object node. That just gives us an object input. We can select the cube up here, click the eyedropper, and the cube is in here. Now, how do we get information out of this object data type here? Well, again, we Shift A, Object. What can we get? We can get transform input. So we plug the object in here, and then we get location, rotation, and scale, which is these values basically from the object properties tab over here. Location, rotation, scale. Now it's one object, a single object, nothing is transparent, which gives us a single vector. I can plug that into a viewer. Yes, it's a vector. And the location is 0, 0, 0, because it's in the middle here. Okay, so how do we do something with it? Well, how about we take, maybe let's rotate this cube. So what can we do? We could take the rotation that's coming out of this object transform info here, the input, and then go to rotation, maybe do some math. How about we take the rotation that we have, which is now 0, 0, 0, and then we add 1 degree on the z-axis, okay? Now, why is nothing happening? I'm changing the value here, nothing's happening. Maybe let's hit play. Nothing's happening. Why is that? Because, yes, we're taking the information from the object, we're taking the rotation information, we're adding a single degree to the z-axis, but we're not doing anything with it. And that is a basic concept, a core concept of animation nodes, and you can find that in many, many different situations. For example, the transform input that we're already using here in our node tree has a transform output. And that's actually assigning, for example, a rotation. If we enable X, Y, Z, or just one of the axes, we can now tell animation nodes, hey, this object here, which could be the same object, so let's plug it in here. This object, I want to set the rotation. I want to set the rotation to this rotation value that I calculated here. So this is the getter. I'm getting information out of the object. This is a setter. I'm setting information onto an object. Nothing is going to happen unless I do the output, unless I invoke the setter node. And this is a concept that repeats many times here in animation nodes. So we can get a matrix input and a matrix output. We could get an attribute input and an output. This just gets the value. This actually sets the value. Or the mesh, we can get the mesh info or mesh input from an object and then change the mesh data. But if we want to assign it to a real object and actually make it visible and usable, we have to take the mesh object output node, where we can take an object and give it a new mesh. Okay, so it's always input, do something with it, output. Now I'm taking the rotation, I'm assigning 1 degree, and I'm setting that rotation to the cube. And you can see here we're already up to 5 degrees. Now, remember in the first tutorial, I told you that we have auto execution enabled. Whenever we change the tree or a frame down here, or a property, then this gets executed. And every time it gets executed, we're adding a single degree. So let's see if that's true. We are at 5 degrees. I'm going to just add something. And we're at 6 degrees. Because the node tree got executed and the cube rotated a little. What if I change the frame here? Yes, every time I change, when I move the cursor here, a single degree is being added to the Z rotation. No matter if I go forward or back, no matter if I take a number integer and change the value here. Every time I change something, this gets executed, and we're already up to 653 degrees. So we're always rotating forward, and we're actually changing the C rotation because we're assigning our calculated new rotation value to our object, and we're assigning it to the same object that we're taking it from. Okay, so what if we have another object, maybe a monkey? And instead of assigning our new rotation to the object, the cube that we're taking the rotation from, let's now assign the rotation to the monkey. So every time I change the frame here, nothing happens. Why? Because this doesn't rotate anymore. So we're taking the rotation, assigning it to the monkey, and that's it. So what if I rotate the cube now? Again, nothing happens. Why is nothing happening? Because the node tree isn't being executed. I switched off always. So let's switch on always. Now I'm rotating the cube. And because this here is always executed, you can see down here, it's constantly executing this node tree. It's assigning the rotation of the cube to the monkey in all three axes, of course. Now there is a feature here that I like to use. Instead of always, we can actually add a trigger, and I'm just going to show you how that works. So we need to execute this node tree here when we change the rotation, because that's what we want to do here. So how about we just add a new trigger based on an object. You can have object collection or scene. So we want it based on an object, and we need something that this trigger can watch. And when that value changes, it will trigger a node tree execution. What do we want to watch? We want to watch the rotation of the cube. So going over here, right-clicking on one of the rotation fields and go to copy data path. Now that's in the system clipboard. We plug that into our trigger here. First we have to select the cube here, this one that we're using. And then we paste the copied value from our rotation Euler, that's what it's called. If you remember that, you can type it in, or you can always go to some property over here, right click and copy data path. What is the location called? It's just called location, but we want rotation, so copy data path, paste that in here, rotation Euler. Now animation nodes, this node tree is watching the rotation Euler of our cube 1 and fires an execution when I change the rotation. Let's try this. I'm rotating the cube, and yes, the monkey is rotating with it. Even though this is switched, all of this is switched off, it's still firing because we have a trigger here, and we can add even more triggers. Okay, so we have input, we do something, then we have an output. We're actually just changing the value here. And let's go back to this, hit play. Now this cube is rotating on the z-axis. We're always adding 1 degree. But we're actually changing the value here. Let me just delete this quick and set this back to 0. Maybe go back and hit play again. We're changing the value. And this change is a destructive change. You know, we don't know. What if I go in here now, go to the first frame, hit Alt R to reset location, and then I want to rotate it 45 degrees here and maybe 90 degrees on the x-axis to get this. And as soon as I change something here and this tree gets executed, it's gonna mess up my C rotation. How can I get this setup, this rotation, this location, this scale that I started with before I destroyed it with my animation nodes? There is something called an ID key. And up here in the 3D viewport, You can also hit N, which brings up this menu on the right here, and there is a tab called AN, which stands, of course, for animation nodes. And each object has an ID key. The initial transforms is an ID key. And we can access that information. We can actually set that information, that ID key. So if I want to rotate my cube to this is what I want to start with. Maybe do some numbers that we can actually check then. Do 35, 45, 30. That's the rotation that I want. I set my initial transforms ID key from current transform. So I click that button. Okay. And it sets this, whatever I have here, into my initial transforms. Now I hit play. I am destroying my rotation here. What if I add 2 on the Y and 0.2 on the X? And now I'm really destroying whatever I had. I don't remember, but it's stored in the ID key. And if I want to access that, I can go to Object, ID key, take the same object, so my cube, click on Choose ID key, the initial transforms, and here we have location, rotation, and scale. And let's just plug in a viewer here. This is going to give us our original rotation of 35, 45, 30. Even though it is now transformed or rotated to 69, whatever this is, we still have the original initial transform information stored for this object. And this can come in very handy, for example, if we don't want to base our calculation on whatever the transform is right now, but maybe want to base it on our original transform. Now you can see that basically nothing's happening because we're always just adding whatever is in here to this initial rotation that we had, and that just gives us a new rotation, but nothing's animated. It's just that we can now add a rotation to our initial transform, and that's the output. I hope that makes sense. You can always get the current transform, do something with it, and then change the actual transform using the object transform input and the object transform output. What if I delete all of that and instead I take my cube, maybe go back to the start here, and if I don't take the transform input and output, what if I take a matrix input for that object? Now I have a matrix here. Remember, matrix is a combination of location, rotation, and scale. Now I could do something to the matrix. Of course, I'm going to need some matrix math, maybe a matrix offset. Take the matrix. Oh, what's happening? Animation Nodes added a node for me because this node takes a list. You can see here it's transparent. It always wants a list, but here I only have one. So Animation Nodes automatically added a create matrix list for me with a single element. Now I want to offset the location of my cube with a certain transform, which is a single vector, basically. Oh no, it's a list of vectors. I'm just going to transform it 0.1 on the X. I want to change the location. You can see nothing's happening to the cube, again, because I'm just doing stuff, but I'm not assigning it to anything. So, just like before, I need a matrix. I need an object matrix output. I want to transform this object after I did my matrix math to a new matrix. But here I have a list of matrices. Here I can only transform one object to one new matrix. So let's go to list, get an element. Whoops, from this list, get index 0, which is the first element. Now I have one single element here, can plug that in here. And now every time a frame changes, because this is enabled, my cube is going to wander away from the center every time I'm adding 0.1 on the x-axis. again, this is just to demonstrate that we have input, which reads the data, then you do stuff with the data, and then you have an output to actually change something in your scene. I hope you enjoyed this video. If you have any questions, write a comment below. Don't forget to like and subscribe. I really appreciate it. See you in the next episode.